All right, let's talk about a similar triangle, parts of similar triangles. So first thing is altitudes. Uh, you see in these pictures, these are altitudes. Altitudes of uh, triangles. Altitude is a measure from a vertex to the opposite side that is perpendicular to the opposite side. That's what it means to be an altitude out of that. So it's just the going from one corner to the opposite side and getting a 90-degree angle there. So if two triangles are similar, then the corresponding parts are also proportional to the corresponding sides. So we could set up our altitudes should be proportional. So like BD over FH would be equal to the corresponding one of the sets of corresponding sides. It doesn't matter. It depends on what which ones you have, but you got to have corresponding sides to that. So if we're going to do that, we could do BC over FG, but it could also be AC over EG. It doesn't matter. It just the other side just has to be corresponding sides to get that ratio that should be the same. Okay. Yeah, correspond. Just a pair of corresponding sides is what the one side of the ratio or proportion needs to be, and then the altitudes are also proportional. And there's our fun thing. All right, angle bisectors out of that are proportional. Same kind of idea. The length of that angle bisector is going to create proportional things there. So set us up a ratio for that angle bisector. Laid it up here and I've lost it. What would be the angle bisector there for the first triangle? QS over UW, and then pick a pair of corresponding sides. It doesn't matter which one. I'll do QR over U. No, just if you've got one of the other sides, it should be the same. The ratio is still the same. Out of that. Medians of triangles, that is a line that comes from a vertex to the opposite side and intersects at the midpoint of the other side. Okay, so medians are also proportional. Same idea. Okay, it's not a perpendicular bisector, but it just the end point of that segment is at the midpoint of the opposite side. So we'd have HJ over LN, and then one of the other corresponding sides. So HI over LM would work. But it's just a pair of corresponding sides. Doesn't necessarily have to be perfect. Okay. Easy stuff. Let's try to do a little bit of work here. So triangle STU is similar. They give us a similarity statement, so that helps us set up our ratios to deal with this one. So what are those things called in this picture, the lines that are in the middle? Those are medians because we see this notation for the congruence on those pieces there. So that's just knowing what that is can be helpful. But it still sets up a proportion. So what would our proportion be for this one? Or what could a possible proportion? So X over 15. And then let's get a corresponding side set.
24, or no, 16 over 24.
So yeah, I put X on top, so we got to come from that one. So TS and is 16 is TS. So where does it correspond to in the other triangle? 20 DE. So you got to make sure you follow that. If you got a similarity statement, you got to follow it and be careful of that. That's how you can mess up here. Simplify that. Be 4 over 5, and then
5x equals 60, x is 12. From there, we can do maybe a little something else. Number 2. What are those lines that are in the middle there that where the 10 and the 8 are?
Altitudes, because they meet the other side at a 90-degree angle, so that's how we know it's an altitude. Out of that, just kind of recognizing some vocabulary as we go along here. So how could we set this one up to find x? 10 over 8.
X over 14. Side HI goes with side LK. Yeah, so that works. I'm going to simplify 5 over 4. And then be 70 equals 4x. Okay. 35 over 2 or 17.5. Yeah. Boring stuff here. It's the same old thing over and over. I'm not sure how to answer that. There's so many negatives in that. I'm not sure. No. No proofs with this stuff. There ain't no proofs, isn't there? Is that what that's what you said?
That's all it is. But no, we're not going to do this section. All right, so number 3. Those are angle bisectors. That's nice to know. What does that do?
32 over 24 and 38 over.
Okay, side of AC goes with EF, and that's the ratio.
If you do 32 over 24, got to do 38 over x. Simplify 4 over 3. 4x is equal to 90 plus 24. 114. Is that the right number? 114? Yay. I get when I do math right. And does that go evenly?
No.
All right, so reduces to what? 57 over 2 or 28 and a half. All right, so another presentation there on 4. It's a little bit different. Those dotted lines do not, they're like imaginary. They don't exist, but they help us find those things that are marked. What are those things that are marked? The 15 and the 12. So what happens at right angles? What are those things? Are they angle bisectors, medians, or altitudes? They're altitudes because they meet at a 90-degree angle there. Using that, we can find the length of x there, hopefully. X over, yeah, I got it. P, Q goes with UT, yeah. X over 42. Simplify 4/5. 4 times 42 be 168. And I know that doesn't go evenly. 168 over 5 or what? 33 and a half. 33.5? 0.6, yeah. I was going to say, I don't think it could be 0.5. Doesn't work when you divide by 5. All right. Number 5, do a little algebra. Yay. At least it's a little more interesting. What are those? Medians, yeah, because they're meeting at the midpoints of the opposite side. Set up a ratio here. 20 over x minus 5. Y'all weird. Y'all put the x minus 5 in the bottom. So YC goes with LH, yeah, so 2x minus 9 over 15. No reducing I can do. 20 times 15 is what? 300. And then we got x minus 5 times 2x minus 9. Y'all agree? -10 and -9. Yeah, that's right. All right, now what do we have to do? Is it equal to 0? Minus 255. And then how are we solving that? Right. 2 times negative 255 would be negative 510. 15 and negative how much? 34. Good job. 2x squared minus 34x plus 15x minus 255. Root. And so we got 2x plus 15 and x minus 17. So that's going to be negative 15 over 2 and 17. Well, you tell me. Why not? And the side length, when you plug that in, stays negative, right? So they can't have a negative median length there, so that's definitely out. 17 does work, though. Yeah, so got to keep that in mind as you're working here. Yeah, you need to check both of them. You can't have a distance, yeah, the length of a segment or a side of a triangle or wherever x is can't be a negative after you plug it in. That doesn't mean you can't get a negative answer and it work. You just check them, especially when you get two answers out of that. The triangle bisector theorem. So this is one of them y'all discovered on Khan Academy we hadn't gotten to yet. And so I've extended all those to the end of next week anyway. So triangle bisector theorem, an angle bisector in a triangle separates the opposite sides into two segments that are proportional to the lengths of the other two sides. Okay, so angle bisector takes the two segments that it creates. What are the two segments it creates? AD and DC, right? They're not congruent. They're proportional. That's the key here is they're not congruent. They are proportional. And you can't see that orange up there. Change that. Okay, and then excuse me. the other two sides. So other two sides. Let's set up that ratio. How would that looking at this picture, how logically would we set that other side up for the ratio? BA and BC. Why BA on top? Mm-hmm. Yeah. And it matters on the others too. Just the same idea there.
So what do you put B?
But BA is going to go on top because it corresponds to the side that AD is on. It's the side of the triangle that segment's on. And then DC on the bottom goes to BC because that's the side of the triangle that segment's on. Basically. Think about it cutting the triangle in two in the pieces there out of that. All right, so let's use that a little bit. So let's set up a ratio here or a proportion to do number 6. job. Cross multiply. I don't, what's 4.8 times 18?
Wait a minute. Why do we do it like that?
Does it matter? Like,
That's what I was thinking.
oh, yep. I bet it's gonna get the same answer though.
Oh, that's confusing.
4.8 over x. And then 12 over 18. 12x. Still, what's 4.8 times 18? Still gotta know that.
Do you not get 6 out of that?
You could simplify if you want to, it doesn't matter. $86.4 divided by 12. $7.2. And the way Logan said set it up, you still get 7.2 that way. Here's what happens. It creates two similar triangles when that happens. That these triangles are similar by side angle side is really what happens. That's why you could set it up different ways and it worked. Number 7, set that one up. KM in the instruction says it's the angle bisector. They don't put the notation in there. If they didn't tell you that, they would have to have that notation that those two angles are equal to each other for you to know that. But they said it in the instructions. So, all right, set up. Good job. I'm going to simplify that one. 40 and 36. Be 10 over 9. Yeah, that's a lot easier. 10x equals 9 times. How much? 486. And divide that by 10. 48.6, or the decimal for that. I mean, that's the decimal for that. What's the something over 5? 243. Bring me all the fraction money you get. All right. What do we got to do in number 8? It's a little bit different. Okay, so we know that that's what's going on. Then we set up a proportion. Right? I think we need to work that one. What about number 9? What's different about that one? Ooh, yikes. So how much is this? X minus 12. And then you can set up your proportion and work it like you guys know how. Okay. Last one. We'll do this one next. Set them in. Set me up here. ML is 18. So we can set up 18 over 27 equals x plus 11 over 3x minus 9. Oh, God, I was hoping it'd be a factor problem. Maybe. Bet I'd get the same answer, though. All right, so cross multiply, or simplify and then cross multiply. 2/3. The 6x minus 18 equals 3x plus 33. 3x is equal to 43 plus 8 is 51. 17 again. And yeah, find KL, so 17 plus 11. 28. Fun, boring stuff.